So today we're going to talk about continuity. Now I'm going to tell you guys right now, continuity is so super important for your AP. So super important. It is all over the AP exam. It will be all over my tests. So please pay very, very careful attention to this. If you don't get this, we're going to have some trouble. Not that it's a difficult concept, but you have to memorize certain things, and I'll tell you what those things are. Okay, so I know that when you took pre-calc, you did discuss continuity. So I want you to read this sentence. It says, no holes or breaks in the graph. That's what continuity means. Just think, continuous. Okay, no holes or breaks in the graph. So I'm just going to stop right here. So if I look right here, where is there a hole or a break? Do you see that at x equals -2, there's a hole down here, and there's a huge break between this piece of the graph and this piece of the graph, right? Okay, now also, there's a hole right here at x equals 3. So that would also mean that that graph is not continuous at x equals 3. So by looking at the picture, we can say the graph is not continuous at x equals -2 and not continuous at x equals 3. Now let's read the second sentence. It says, if you can trace over a curve with your pen and never have to pick it up, then the graph is continuous. So let's say I asked you, is the graph, this graph right here, continuous between x equals -1 and x equals +2? So what if I only focus right in between this domain between -1 and 2? And can you see that I never have to pick up my pen, or my pointer in this case? Okay, so do you see that between -1 and 2, the graph is continuous? Just like maybe between -4 and -2. So between -4 and -2, this graph is continuous. So we can always close in the domain, but if we are looking at this entire picture, we have discontinuity. Okay, so here are the 3 rules right here to prove continuity. This is what you're going to have to memorize. Now, this will make sense once I explain it, I hope anyway. So it says here, the limit as x approaches c from the negative direction of f of x is equal to the limit as x approaches c from the positive direction of f of x. Okay, now again, this is on page 19 in your notes, so anything you need to add to page 19, go ahead and add it if it's going to help you understand it better. Now look, so this is basically saying the limit from the left equals the limit from the right. Isn't that what that's saying? So this side here is the left limit, and this side over here is the right limit. So if the limit from the left equals the limit from the right, doesn't that mean the limit exists? And that is what this is saying right here. We just finished doing that. So if your limit from the left equals your limit from the right, then we know the limit exists. So that's one thing you need to have for continuity. And that's why we don't have that here at -2, because the limit coming from the left is +2, and the limit coming from the right is all the way down at -1. We don't have continuity there because the limit from the left does not equal the limit from the right. Okay? All right, let's look at number 2. The next thing is f of c has to exist. So whatever number is here and here would have to be in here also. So let me give you an example. Let's talk about at x equals 0. Okay, so here's x equals 0 right in that spot right there, right? All right, so let's look at rule number 1. It says the limit from the left equals the limit from the right. Now let's see if that's true. Coming from the left, it approaches 1. Coming from the right, it approaches 1. So we can kind of do a little check. We know that this is true. The limit exists. Now, when it says f of c exists, in this case, c is going to be 0. So do we have a closed-in circle at x equals 0? And let's look. At x equals 0, there's our closed-in circle, and do you see that that's at 0, 1? So the limit from the left up here, remember, we said approaches 1. The limit from the right approaches 1. And f of c is also 1. So then we can check that one off. So we're 2 for 2 on that, if we were going about x equals 0. All right, then let's look at this last part. It says the limit of the function as x approaches c equals f of c. So really all this is saying is, does your answer to number 1 equal your answer to number 2? And it does. Limit from the left approaches 1, limit from the right approaches 1, and f of 0 is also 1. So then we know that it is continuous about x equals 0. Now, let's take another one. Let's look at x equals 3. So if I am coming from the left, right, I'm going in this direction, do you see that limit is going to be 0? And then if I'm coming from the right, do you see that limit is also 0? So then what that means is I am right here on step 1, I know that limit as x approaches 3 is 0. So the limit exists. Now let's go to step 2. It says f of c exists. So f of 3. So let's look and see what f of 3 is. Well, f of 3 is -1. That works. So I can check off number 1 and I can, and I can check off number 2. Here's the problem. Step 3, does the limit equal f of c? Well, the limit from the left and the right equals 0, but f of c equals -1. And this says they have to be equal to one another. So if I were asking, is this function here continuous at x equals 3, you would say no. Okay, because the limit does not equal f of c. Now, if you go back up here, you can read my second sentence, and it says if you can trace over a curve with your pen and never have to pick it up, then it's continuous. Well, I have to pick it up. If I was going along here with my little green arrow, I have to pick it up to go over that open circle. So that means it's not continuous there. Whereas over here, I started, I do have a closed circle. I can keep going. I don't need to hop over it. Okay, so hopefully you see the difference. And that is what continuity means. Okay, I am telling you, I cannot stress to you enough, you had better know what's in this box like the back of your hand. And I hope you know the back of your hand really well. Okay, then intermediate value theorem. Guys, this is going to kind of seem like a stupid thing to even do. I'm going to explain it, but I'm going to tell you, once we start going through AP questions with it, it's very easy. You'll be like, oh, is that what this means? It's easier once we do some examples. Basically, this is what it says. When you have 2 points connected by a curve, so here we got point A, we have point B, and let's just say you have a curve and it looks like this. Okay, notice that one of the points is below the line and the other one is above this line that they made here. So basically I got a point below the line and I've got a point above the line. So this is what intermediate value says. Basically, if I were to draw a line, then the graph has to hit that line at least in one spot. Okay, then there will be at least one place where the curve crosses the line. Right? Now, let me just give you, for instance, if this was the original point, right, and this is the end point, maybe the graph could have gone like this, for all I know. Okay, now, I know that's just a gorgeous graph, but look how many times it hits the line. 1, 2, 3, 4, 5 times. Read what this says. There will be at least one place where the curve crosses the line. So in other words, I can't get from point A to point B unless I come across that line. Okay, that's all intermediate value theorem says. And again, once we do some questions like that involve intermediate value theorem, it'll make a lot of sense and you'll be like, oh, okay. All right, so I want you to turn the page in your notes and let's go to page 20. We're going to look at number 1 and please just make sure that you're taking notes. Okay? All right, so this is asking to determine whether the function is continuous. Now, if you remember on the previous page, continuity, we got to have a limit from the left equals a limit from the right. So I'm going to start with that. And it says at the given value of x, so at x equals 3. So basically, do you see here that these values are less than 3? Or equal to in this case, but less than 3. So that means this encompasses the limit coming from the left. And then these domain values are when x is greater than 3. So that means this encompasses the limit from the right. So if we want to see whether those guys are equal, all we do is take this value and plug it in here and see if we get the same thing. Okay? All right, so let's do it. So if I plug it into the top, I'm just going to put it out here because I can fit it. I'm going to plug in that 3. I'm going to get the square root of 4, right? Which is really just 2. Now let's plug it into the bottom part of that piecewise function, and let's see what we get. So I'm going to plug in 3, and I'm going to get 5 minus 3, which is also 2. So what you have just proven is that the limit from the left equals the limit from the right. So if you look back on page 19, the first thing that we need to prove about continuity or deciding whether something is continuous is to prove the limit from the left equals the limit from the right. So that's what we just did here. Now the second thing is to determine if there's an f of c, in this case an f of 3. Okay, so we're going to determine whether or not we have an f of 3. So very easy. Go to your piecewise function, look at your domain, look at this domain. Which one contains 3? This one, right? So you plug in 3 here. Well, why should we reinvent the wheel? We know what that is. That's 2. So f of 3 is 2. So if you go back to page 19, the second step there says we have to have a value, in this case at f of 3, which we do. All right, then the last thing says, does your limit, which is this, equal your f of 3 in this case? And yes, it does. So is this continuous? Yes, it is. Okay, so determine whether it's continuous. I'm going to say yes. Now, I would show this work. It's not an overwhelming amount of work. You're not going to die from it, so we're good to go. All right, I'm going to skip number 2. Let's go to number 3. We're going to do the same exact thing again. Now, this says that x equals 1. So just quickly, this is the limit coming from the left because this domain represents numbers that are less than 1. And this is the limit coming from the right because these values are greater than 1. Again, we're going to plug in 1 here, and again, we're going to plug in 1 here. Maybe you want to pause me, work that out, and see what you get. Okay, so put me on pause. All right, so if I do that, I have -4 in the top part of the piecewise function, and I have 1 in the bottom part of the piecewise function. Uh-oh. So listen, guys, we're done. We don't have to go any further. Because those are not the same, your limit does not exist. Because your limit from the left here is -4, and the limit from the right here is +1. Okay, so your limit as, I should say of, f of x as x approaches 1 equals, I can't fit it, so I'm going to write it up here, is a DNE. So that's why it's not continuous. So I'm going to write no. Okay? All right. Now, I want you to turn page, look on page 21, and the next one we're going to do is number 5. All right, I cut off number 5, so I replaced number 7 with number 5 because I'm not doing number 7 anyway. But so here's number 5 down here. Now it does say at x equals 0, so remember, just like the last one, we're going to plug in 0 here. Now, remember this though is your limit coming from the right-hand side because these numbers are greater than 0. And this is your limit coming from the left-hand side because these numbers are less than 0. So plug in 0 here, plug in 0 here, and let's see what we end up getting. All right, so if I plug in 0 into the top part of that piecewise function, I would hope that you would see that you would get 4. And into the bottom part, I also get 4. So that means your limit exists, right? Because the top part of the piecewise function equals the bottom part of the piecewise function. Now, the other thing that we need to look at is, do we have f of 0? Let's see. Well, remember we're supposed to go to the domain and figure out where we have the actual value of x being 0. And it's not here, and it's not here. So even though my limit exists, I don't have f of 0. So in other words, my picture, so my picture could maybe look something like this. I'm approaching 4 and from the left and 4 from the right, but at x equals 0, I would have a hole. And because I don't have a value here at f of 0, right, we have no value there, then we have to say that my function that I just kind of sketched up here is not continuous. All right, so for number 6, we're back to just a regular function, not a piecewise function. And I actually want you to determine whether or not it's continuous at 2 points. The first one's going to be at x equals 7. So what I would suggest that you do is just throw in that 7 in for x. So 7 minus 5, and that's the 4th root, right? So that's basically going to be the 4th root of 2. That works. Now, let's do the same thing, and I'm going to explain that a little bit more, so I will go back to that. Let's do the same thing for the next one. If I plug in 5 here, I've got the 4th root. My stylus here would make a 4, we'd be good. And then I'm going to have 5 minus 5, which is 0, right? So the 4th root of 0 would just be 0. So a lot of students would think, oh, the answer is 0, and it's actually not. And so this is a trick. So I'm going to tell you that whenever you do anything with continuity and you have a square root, this is what you need to think. Remember on your summer assignment that I hope that you did, and you memorized those 10 graphs, which I hope that you did, you know what a square root looks like. Now, I'm going to tell you that if I want to know where this square root hits the x-axis, and I don't have a calculator, I just ask myself, what number can I put in here to make what's underneath this square root? I know it's a 4th root, it doesn't matter though, to make it 0. So do you see that that would be 5? So that gives me my x-intercept. Okay, so I'm going to go over here to the graph. Here's 5, and I know a square root looks like that. Okay? All right, so now knowing that, let's go back and I want to talk a little bit more about x equals 7. So if the x-intercept here, it hits the x-axis at 5, then well, at x equals 7, do you see that it would have to be continuous there? And let me just kind of, here's x equals 7, okay? So if let's pretend that was 7 right there. All right, so basically the limit coming from the left and the limit coming from the right equal the same thing, and f of 7 is also the same thing. So it's whatever the 4th root of 2 is, I have no idea. Okay, so that's why that works. Now, this is why the answer is not 0, because remember, continuity, the very first thing we have to look for is the limit from the left and the limit from the right. Well, if we're at x equals 5, look at this. The limit from the right approaches 0, but hello, there is no limit coming from the left. So if the limit from the left doesn't even exist, obviously the limit at x equals 5 can't exist either. So therefore, is number 6 continuous at x equals 5? Your answer is going to be no. Okay, so over here on the left, is it continuous at x equals 7? My answer is yes. Over here, your answer is no. Okay, because the limit from the left doesn't equal the limit from the right. So as I said to you, I'm going to tell you that when you have square roots, if you end up getting 0 as an answer, I would let those bells and whistles go off inside your brain saying, something's not right. Let me draw the picture, and remember, the x-intercept is always wherever this expression underneath the radical is equal to 0, and that's at 5. And then when you draw that picture, and this is also at x equals 5, that's where we got problems. Okay? All right, let's look at number 8. And I know in your packet it doesn't say it, but hopefully I remembered to tell you in class. If I didn't, I want to look at x equals 2 and x equals negative 2. And I'm going to explain why as we go through it. All right, so let's say, kind of like number 6, we're going to look at 2 values. So let's look at x equals 2 first. Okay, well, if I plug in 2 right there, right, I'm going to end up with the ln of 3 times 2, which is 6, and 6 minus 4 is 2. Now, I don't know the numerical value of that without a calculator, but this is okay, and I'm going to explain why it's okay in a minute. But let's go to x equals negative 2, and I'm going to explain why this is not okay. If you plug in to this expression here, negative 2, okay, do the work, that's negative 6 minus 4, that's negative 10, right? So the ln of negative 10. Now, I told you that a lot of this class is no calculator. I would tell you to go cheat for a second, find a calculator, and do the ln of 2, and do the ln of negative 10. You're going to end up getting an error here. You can't have an ln of a negative number or 0. Okay, so I'm going to repeat that again. You can never have an ln of 0 or a negative number. So since this is a negative number, your answer is no. It is discontinuous, or it's not continuous. I don't care how you say it. Okay, so this is not continuous, no. However, on the right, it is, because you can have an ln of anything that's 1 or higher, and you've got the ln of 2, so that's good. Okay, so you can't have ln's of 0 and you can't have ln's of negative numbers. And again, grab yourself a calculator and double check. Take the ln of any negative number or the ln of 0. You're going to get an error. Okie doke? All right, last 2 questions. So turn the page to page 22. This one's a little bit different. It says find the constants a and b. So we're looking for a and b such that the function is continuous. We're assuming continuity. So guys, if you're assuming continuity, basically, I'm going to look at these domains, and do you see they both have 2 in them? That means I can plug in 2 here and 2 here. And then I'm going to set them equal to each other, because if things are continuous, when I plug in everything, they should be equivalent to one another, right? All right, so let's just go for it, and let's see what we end up with. So if I plug in 2 to the top, you're going to see how, hopefully, that you're going to get 8, right? Now, here's the thing. If I plug in 2 to the bottom, I'm going to end up with 4a. But I do know if this is continuous, which the directions are saying that they are, that I know that 4a has to equal 8. So then you can divide both sides by 4, and you can see that a is 2. And there's your answer. Pretty easy, right? Okay, number 2. Now, I did not tell you this. I think you learned it in pre-calc last year, but if you didn't, here it goes. So same deal. These 2 guys, the 2 parts of the piecewise function have to be equal to one another. There's a little known fact right here. It's called the sandwich theorem. Do not ask me why it's called the sandwich theorem. But if you ever have the limit of a function, or I should say, the limit of sine x over x, which is kind of what I have here with a 4 in front, but we'll deal with that in a second, as x approaches 0. Okay, now look, this is as x approaches 0. So whenever you have sine x over x, now again, I'll deal with this number in a minute. We know, it's just a known fact in calculus, that that is equal to 1. Okay, now what I could do, and I don't know that you really care, but take my word for it, if you plug this into your y1 in the calculator and you look at the picture, you'll see as you come from the left of 0 and the right of 0, the graph is going to be approaching a 1. Okay, so basically all I'm going to do here in the top part of the piecewise function is I have that 4, and I know sine x over x, that's going to be a 1. So I know that that's 4. Okay, so anytime you see sine x over x, that equals 1. So if I were you, I would probably box this off, star it, because you're going to need to know that. Now, if you want to write that at the top of the page, wherever you need to write it so that you remember that. Okay, and you'll see it again. It's not like you're never going to see it, but All right, then let's look at the bottom part. So then the bottom part of the piecewise function, we're also going to be plugging in 0, right? So I'm going to get a minus 2. Oops, times 0, which is going to be a, right? Well, geez, that was really super easy. And remember, if they're going to be continuous, then I know that the 4 has to equal the a value. And there you go.